G'day guys, it's going to get comfortable here. As you can see, there's a 5000 behind me, and a while ago I said I was going to make up modules for these detectors that you can install yourself. Well, let's move that around a bit there. There we go. That's better, I think. Yeah, it's making sure this tripod's getting a bit wobbly, so I don't want the leg to fall off or anything like that. Anyway, on the bench there, I was going to do a complete demonstration of this, but I want to epoxy it. And the two-part epoxy I've got, I think it's got no cure time on it. I think it's 24-hour cure. So I can't move it. Anyway, it's on the bench there. That's it there, if you can see it. Now maybe I'll move those detectors and move this in a bit. There we go, a bit of an earthquake. But there's a few things that I have refined, and it's quite critical to refine a few things. So there's our miniaturized module right there, and I've got it sitting in a 3D printed little holder, I suppose, a little potting box. So I've had to I made a mix up of this stuff here. As you can see, it's still wet and sticky. I just used a cotton bud to mix it up. And yeah, I'm spinning around trying to find stuff. So yeah, got a bag of boards. So I think there's 130. I ordered 100 boards just for testing, and they sent me 130. So and that was PCB cart. I use different ones for different projects, and yeah, I got PCB cart. General Electronics actually is the company that owns it. They're cheap, so we've got a stack of boards and a stack of parts. And the one thing that needs changing if you're going to do this is on this particular one here. That's not it. That's a different thing altogether. But it's, okay, if that thing there had an extra leg on it, dear me, it will be the right part, but it's not. That's a top tab and two legs, and the one leg in the middle usually goes to the top tabs. So goes gate, then drain, then source. And if you want to know how to hook any MOSFET up, it's easy to remember. The gate is what it is. You know, open or close, put voltage there or not. And if you look at it this way, you're on a N-channel device anyway. Very easy to remember. Gate, drain, and source. They're your connections. So you remember, things go down the drain. So the flow is from positive down to negative, and the source always ends up on the floor, right? So gate, drain, and source. So if you want to play around with MOSFET, it's a good way to remember it. Down the drain, and the source ends up on the floor, which is your negative, and your gate turns it on and off. So if you stuck a light bulb between the positive rail, and then you stuck the other end of the light bulb onto the drain connection, and you put a little tiny positive voltage of about 5 volts or so on the gate, light bulb will turn on, and if you take your finger off, it'll stay on until you short the gate, lick your finger and touch it to ground or source. and then it'll just discharge it. It's like a capacitor inside. So that's just a handy way of remembering which way they go around. So yeah, anyway, for this upgrade, we have to change that MOSFET, which I'm trying to remember what it is. It's a diodes or ZX, old ZX or ZTEX. Suppose if you're in America, you'd say ZTEX. Or is it ZX? Whatever. But it's now called diodes. So I don't think we get that wrong. Diode. Good name for a company. They make diodes, but they make MOSFETs and bipolar transistors too. So maybe they should have called themselves semiconductors. I don't know. Anyway, ZVN. God, I try to remember. 2260, I think it is. ZVN 2260 is the device that is on the board, and I can show you on another board. Here's the one that came off the quad bike and hit a tree, and this detector never went again. So yeah, it's shattered the internals of the board. Just complete write-off. Yeah. So on the back of the board, and if we turn him around that way, as you can see, I tried fixing it because there was problems in the drive to the a power FET on the other side of the board, and yeah, there was other issues. Anyway, long time ago, and yeah, dead detector. So it never got fixed up. The device that needs to come off the board is that one there, that thing. All right, and maybe if I had a black texter, which I do, I'll just mark it. I'll just draw an outline around it so you know what it is. There you go. Around there, 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 around there. If you can see that, I've put black texture around it. That one there. So that comes out of circuit. And to get that off circuit, you can use a hot air tool, but you've got to lift the back tab. And a good way to do it is you can solder suck it, and it's a bit curly. You really do have to melt the solder on the front 3 legs there and the tab all at the same time. You can do it with hot air, or there's ways and means. If you're very quick with your iron, you melt the tab and you put a whole heap of low temperature solder on the tab, and that allows it to stay wet for longer, and then you just heat up the front ones. These are also stuck down with something that is like super glue, and you've got to get it hot enough for it to break the bond, or you get some sharp blade under there as well, and just crack it, and make sure all the pads are hot and molten, or else you're going to rip the pads off the board. So that does have to come off the board. And the little module we make, because it's in a plastic housing now, you can stick it anywhere you want. I actually stuck it on top of that device there, that at the end of my finger. I stuck it on top of that. That is a ADG 333, I think, from memory. Yep, because it's not on that side. It's on the GPs on this side, and on the GPXs it's where it is. And that's just it's a nice. Well, actually, it's just a big expensive switch of description. Multiple switches, and it switches below rail. You can do negative rails on it too, and to positive and all sorts. It doesn't really care. So what you do, you get the module, and you just got to stick it well, I'm going to make paperwork up so you can do this, but you're just going to hook up, you're going to take out the gate feeder resistor, which, remember and get it right, is that little thing, I don't know if you can see it, right there. And it's got a protection diode there. It's a BAV99. So you take that out, so you've got the feed coming from, it comes from the other side of the board, actually. It's just a CMOS chip driving it. I'm not going to go give out all the numbers of this stuff because, you know, someone might get their knickers in a knot. And basically, we put a wire on one side of that little tiny resistor, and you can put another wire on the other side where you remove the resistor, you get rid of it, you don't need it, or you can stick it on the gate leg of the FET. And the way this is done, I wish I could pick this up and show you, but I know I will end up pouring all the epoxy out everywhere, and it'll make a hell of a mess. So I'm not going to do that. But what I did on this one, this is really easy to do, and you can keep your detector pretty well looking like it did. What this actually does, you probably want to know what it does. I suppose that's important. This allows you to run any coil you want on the detector, you know, like a coil made for it. I'm not talking something off, you know, a Manticore or something on your PI. No, don't do that, won't work. But any aftermarket coils, the new coils that are a little bit finicky, we'll call, not really finicky, but the older detectors don't like them that much. Well, they will, but if you modify them, they don't like it that much. But this allows you to absolutely tune in the detector for any coil you put on it. It makes a big difference. What we call it, we can call it, there's two things it does that I suppose because it's going to go out there, you can stick an oscilloscope on and measure it and see what it does. It moves a time window of a damping, and you can also adjust it so it gives you critical damping. And what critical damping means is that you need damping, as your coil's going to ring forever, and it's going to be as noisy as hell, and you won't pick anything up. So they're going to be damped. I could draw it up on the whiteboard and show you how it all works. But basically, it's got the MOSFET in there. It's got a resistor on the MOSFET connected to the coil. One end of the coil goes to ground. The other end's getting switched, and it's got flyback and all sorts of stuff on it. And what actually happens after it does its transmit cycle, goes transmit, bit of dead time, and then transmit, and then dead time comes later. What happens is we go bang with that MOSFET, we turn it on, and that resistor that's in series with the MOSFET gets, the MOSFET and the resistor get put across the coil. Because if you put current in a coil and quickly turn it off, it'll make a huge couple of 1,000-volt flyback, which wants to blow everything to pieces. But the detector's got stuff in there to fix that. So, you know, it bangs that down, says you will behave. And the other thing it happens too is that when you turn off a charged coil, it does this, and it oscillates. And eventually, over a given amount of time, depending on its resistance and its capacitance, basically its reactance, and what's hanging off the cable and everything else you got to take into account, add that capacitance from the cable, and it will ring for a particular amount of time. And you don't want that, because you want to receive in this where it's ringing. You don't want it ringing when you're receiving. You're trying to pick up a signal this big in something that's this big, right? You're not going to hear it. It's going to get swamped. So what actually happens is the coil goes whack with transmit, right? Flyback comes up, and you want to squash that flyback and get rid of that ringing as quickly as possible. You can it's called damping anyway. Damping means like, it's the same thing as putting out a fire, right? You know, you get a big stick with a big wet rag on it, and you can damp it and, you know, stop it flaring up if you want a particular amount of heat. You can do the same thing with with basically the semiconductor. It's not doing heat, but it's controlling the electrons. So what happens? This thing goes bang, whoop, up goes a flyback. You want to knock the flyback down because it'll blow your front end out. So what actually goes on is that it's got protection FETs in the front end, and everything's lopped off at about 100 and the usual 185 volts. The flyback never gets up. It goes onto a control circuit, and it gets squashed down. So it's usually kept at about 185 volts. And then what you want to do is get rid of this ringing. You don't want it there because you can't hear anything from any target signal, right? The coil's going to swamp it out. So you switch this resistor across the coil. And what that does is the energy from the ringing gets swamped out by the resistance. So it's meant to go, oh, and just pull down the ground, more or less. But the thing is, it's very interesting. If you use too low a value of resistance, it can actually cause the ripple to go further up the line for longer. And if you don't use enough, the big one won't disappear, and it all goes pear-shaped because you can't turn your receiver on early enough to catch those tiny decaying target signals. So, you know, it does a couple of things. It helps get rid of the flyback, and it also gets rid of the oscillations from the coil. And there is a thing called critical damping. No two coils are the same, okay? Especially with different sizes, different manufacturers. If you actually looked at it on the oscilloscope and you put on a higher amount of damping, something like 1,000 ohms or something like that, and just leave it across the coil and measure the time of the oscillation. No matter what coil you put on there, some will fade off quick and some will extend long. And in these detectors, the damping is fixed, right? It's she'll be right, mate. That should be okay. That's how it works. So what I've done with this module, it allows you to change the depth of damping and the time window of damping. So if I had it up on the oscilloscope, it looks really good. I can show you real easy how it works. And the way you'd find out how it works is you put a tiny bit of gold on the ground and swing over it, and you adjust the damping until you get the most signal with the least noise, and it makes a big difference. So it's just basically altering where you sample on the decay curve, and also the depth of the decay curve and the time window of the decay curve. So there's that little module, and it works really well. And like I say, you do have to change the MOSFET there, and kick the tripod. The funny thing is that the MOSFET that I'm using, it has to have particular parameters. The original one won't work, and thus it has to be removed. You've got to remove it. It will work if you leave it there, but you won't get all the benefit. It just doesn't have the right criteria. So changing that, one MOSFET, and then just wiring in to all you basically need is you need a pot. And what I've done, which I can't move, I've got the pot connected in there. If I move the front panel, it's going to move this thing here. That's what it is. It's going to move it. I'll just see how my glue's going. Oh, it's getting tacky. It may not flow. I don't know. No, it probably still will. But don't want to take the risk. Yeah, basically, it mounts on the board. There's a couple of channels on the box that go down, so you don't put it where the channels are. You could put it in here. You could probably put it over here on this side of the damping and the transmit parts there, or receive, should I say. High voltage control circuit there. You could put it in there. You doesn't make any difference. There's a lot of room. Actually, I'll show you how much room there is in one of these. If I get this gadget here, and I get this board just as a demo, and make sure I put it in the right way, which would help. Doesn't really make much difference, but it goes in that way. Okay, so there's your board, and you can see a little. There's a channel there. See that channel there? You don't want to mount it on the board so it bangs into that when you put it in. That would be embarrassing. And there's a couple of smaller channels, one there and one there. And you don't put it there either. So you put it either side. Basically, you don't really need to put it one side or the other. It's closer it's better when it's closer to the FET. But if I go around this side, I'm trying to make it so you can see it, but if you get an idea here, that's the little channel is where my finger is. So what you would do is that you'd probably, more or less, you could probably mount it directly on top of the damping MOSFET after you change it. You can actually put it in there. There's enough room. I did measure this. And even at the front here, you could stick it in here. Maybe not, because that's all your receive input switching there. You don't want to have anything that causes a bit of capacitance or a bit of noise leakage or anything like that. Good place to put it. Actually, that you can stick it on top of the power supply there, and yeah, I put it on top of the MOSFET. You can put it in here. I think you put it right next to that ADG 333 and that rectifier diode there for the -5 volts. So that's a good spot to put it. Just put it in there. It's very small. And then the legs are very close to the MOSFET, so you don't have any major reactance going to the MOSFET. Yeah, power supply, you could take it off near the 4053 here. There's a nice clean 5-volt rail there you could take. Ground, you could take it off that ground point there, or you could take it off the other side of that little capacitor there at the end of the 4053. So that's a good supply rail there. The rest of it, I've done all the filtering inside the circuit, so you can have wires hanging off all over the place, and it's not going to pick up stray EMI or even pulses from the coil or anything and cause a drama. Done all the tests on that, and works really, really well. So it's very easy to do. And the other thing, I'm going to show you what I've done so you don't have to drill a hole in your detector. Oh no, don't do that, because a lot of the detectors we do, that it really helps when you put variable frequency in there, so you can nail it for very, very fine gold. You can crank up your pulse repetition rate, and it's much better on smaller gold, so you can nail smaller gold better. Or you've got bad ground and you want to go for bigger targets and ignore a lot of the surface junk like shotgun pellets. Use a bigger coil and turn the frequency back, and it ignores that stuff. It's magic. If someone's got out there and blasted shotguns everywhere, you don't want to waste your time digging up shotgun pellets. Unless you're very, very bored and you don't want to make any money, I suppose. But go for the bigger targets. Go down for stuff no one's really bothered looking for years, and with old technology, they probably walked all over it and left it there. So you got new technology. The detectors are far better. Yes, I speaking of detectors too, I'm going to have Kim sent me a message, and it said about the Gold Monster we did. He's got all the new stuff in the Gold Monster, and he was getting spectacular results on the Gold Monster. Should I dig it up and show you? Probably, because if I don't do it now, I never will. So I'll go find his email, there we go. That board didn't work anyway, so who cares? Hopefully in the meantime, this may solidify. It's very easy to put in. I've just got to put on 4 wires and away it goes. So I'll go over to the computer and I'll see if I can find it. It's only come in today. I've got to be careful because there's schematics in it on my bench. I don't want anyone seeing that. So I'll put that away. You know what schematics are, don't you? It's called monkey see, monkey do. So we better hide all that. So get in here and I'll just check on the computer, just make sure there's nothing up on the screen. Damn it, I've been using AI. I've used all the, what does it say? Resets in 27 minutes. I've been really banging the AI on a lot of design stuff, actually, just running some stuff that, you know, will work. And I just say, well, can it be better? And a lot of times it's gone off on its merry way and it's had major hallucinations, and you've got to say, no, don't go down that path. That's not going to work. But a lot of times that they all say this AI stuff is really, really good. Certain things are really good, and certain things are really stupid. Believe me, it's tried to tell me stuff, and I'm just going, oh God, it's reinventing physics. You know, you can't do that. No. Says dumb things. Doesn't take. You got to talk to it like a baby. Anyway, I've got to find this email. Where are you? God, you've got no idea how many emails I get. Well, it should be just there because it only came in this morning. I saw it when I woke up. There he is, Kim. So, that's his name, but I'm not going to. Hang on a sec. You can read it for yourselves, but I don't want his name and email and stuff all up there. Hang on a second, try that, see if I can make it expand. I can, but it's making the fonts and that bigger. Oh yeah, maybe. Okay. Oh dear. Hang on, can I window that up there? I'm just trying to do this. I just don't want the hang on, if I go all the way down there and I get a, do I need that? No, I don't need that anymore. It's post-it note. So I'll just rip off the front post-it note because I've already written that down. Then you're going to read the post-it note. It's got some stuff on it. But anyway, how about we go there and, oh, I'm going to do 2 post-it notes. But you can read this for yourself, what he said, because I don't want to read it because you'll go, blah, blah, blah. You know, that's not true. Okay, so don't fall off. They're not very sticky. Anyway, I've got the post-it notes there, right? So I don't think there's anything else. No, one's going to fall off and I'll have to remove it. But can you read that? I'll read it anyway. There, here it is. Hey, Woody and David. Thanks for doing the work for me. Just had a play with it at home. Was fun and really interesting. Before, oh, sorry, this isn't the Gold Monster. This is a GP3000. There's another one of the Gold Monster there somewhere. But anyway, I might as well read this. 3000, just as reference. Sorry. Okay, there we go. Did I catch it in time? Probably. I think I did. Putting post-it notes on upside down doesn't really work, does it? That's going to fall off too. They're bloody horrible things, really. They don't really work. Okay, well, here we go. We're going to have 2 hands there. Hey, Woody and David, thanks for doing the work for me. Just had to play with it at home. Was fun and really interesting, right? That's what it says. Before mod on UFO 12 by 24 inch. 50 cents at 680 millimeters. A drink can, 1200 millimeters. With mod, 50 cent went from 680 millimeters to 880 millimeters. And the drink can that was 120 centimeters, okay, went to 145 centimeters. And with 45-inch detector mods coil, oh my God, okay, 45-inch, okay, he's got one of our big coils. 50 cents at 120 centimeters, and the drink can at 2 meters. So there you go. That's how you get big gold. Okay. Yeah, awesome. I'm very happy with it. Cheers, Kim. So that's Kim, and I'm going to grab this bloody camera and rip it away really, really quickly before all these things fall off, because they're going to. Oh dear. Yeah, they're useless, aren't they? Post-it notes. The message you'll leave for people that never, ever, ever receive the message. Jesus. Ugh. Not much stick. So anyway, we'll go back over here and I'll see if this glue's dried a bit more so I can actually fire it up and show you, because if I show you the way it works, I've got it set up here for double D. Double D is not the really best coil to use on this, because the receive damping is in the coil on the receive winding, and you can't do anything with that. That's just a fixture. If it's not particularly perfect, there's nothing you can do about it. I mean, you can damp it more by doing it inside the detector, solder a resistor across the RX input line or something like that. Just leave it there because it's in the coil anyway, robbing power and diminishing signals. But no, what you can do is open your coil up and cut it out and put an adjustable one inside the detector. That's what you can do. But okay, won't go there. But I'll just have a poke of this thing here and see if it's got a bit more solid. So what I'll do, I'll get this. Yeah, okay. Oh no, I'm making tents on it, so it's still sticky. But can I wire it in? Hang on, I'll get rid of the glue. So I've got the glue on this foil that some parts came in. And if I get this detector, I'll show you how to, I'll do it. I know how to do it. I've got to get the detector level. So you stay there. So I'll use my pot of low melting temperature bally solder. I will get this and I'll plonk it up here. Oh, can I do this? I should be able to do it. Okay. I want everything to sit flat, so I'll put my 4-eyes on. Just give me a minute and I'll get this thing soldered in, because it's quite remarkable how it works. It's called Thou Will Get More Gold. Okay. I hope it's stuck good enough so it doesn't actually pop out, but it shouldn't, I hope. Okay. Okay. I want yellow there. This isn't the final color coding. It's just what I use for myself, because I had the wire sitting in front of me. Okay. And for my ground, I'm just going to use that blobby. There we go. I stuck my damn finger in the glue. Yuck. Okay. That's called Murphy's Law. So we got that on. All I do now is put the positive on, and I'm going to take it over near Oh, good. Move it over there. That's my takeoff wire to look at the decay curve on that one. And get on there. You don't want to. You don't want to have this short out or anything when you do this. You've got to be a little bit careful, otherwise you'll blow up the FMMT 718s or 716s. Anyone who works on these will know all about those. Okay, make sure it's not. I just tacked it off that, and now what it's trying to do is trying to pull the board out of the resin. Now, fix this. Oh dear, 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 dear. How about I shove a tube of resin under it and push it up so it doesn't go out? There we go. That may work. Anyway, I don't really care. This is for me. This is my one. So I just wanted to make sure that it's all going to work properly and behave. Now, we need an oscilloscope probe, which is here. And the hardest bit about all this, it's all got to be high speed. You can't have any lag. And if you can see here, I don't know if you can, the oscilloscope probe's in the way now, that I've actually got rid of the poke the thing for scanning frequencies to try and find the quietest part of the spectrum. And I've just taken the push button thing out and I put a pot in there. So if you ever wanted to take it out, it's really easy. You just take the pot out and stick your button back in there. So that's what I say. If you want to sell your detectors in, someone's freaking out because there's all extra knobs and switches on it or something like that, you can put it back to normal. So the only thing you can't do, if we put variable gain on the detector, which is really, really good, it needs there's a provision on the front panel for it, right, which is covered up by a sticker. It's actually a provision for some control, which was probably never installed, or maybe it was an old design and they said, I don't need that, whatever. Maybe it was variable damping. I don't know. So anyway, what we'll do, we'll turn this thing on. Should just work. I'm on ground. That's right. That's right. Make sure. I don't want to get things ran the wrong way, but we'll turn it on. It should work. And I'll give some audio too. So where are we? Okay. I think I'm just going to do a little bit of oh no, I need that high. I'll drop that down and I'll use that. That's right. I had it on extended. So, okay. It's a little bit short. Here we go. There's double looping. Okay. It's showing there's two decay curves. There's not just one. It's just these oscilloscopes on mixed signal, mixed time switching signals, and that they have a hernia. They don't really like it too much. I mean, even that 1.5 gig thing that costs about $50,000 does the same thing. So it's just a thing with oscilloscope. So you can see the decay curve there. Okay. Okay. I'm going to have to just modify this a little bit so you can see. I think that's good enough. You can see that. It's pretty high. I've got the gain right up. How about I just drop the gain? I'm probably on the long pulse or something too. I don't really know. Yeah, I think I am. But anyway, it'll do. So yeah, we'll just we'll crank up the gain a little bit. Yeah, but if you have a look at this, that's really, really hard damped. That's how the detectors are. They're that hard damped. Now, if I turn the variable damping control, because the time window goes out, hang on. I should have set it up and locked it properly, but oh, there we go. See, that's going right up. It's gone off screen actually, but we'll do that. Have a look at that. Oh. Hang on, let's go to the level. It's something's maybe I got to crank too far. I had it before. It was really, as soon as I pulled it apart. Let's have a look here. Oh, okay. Probably is best I'm going to get it. You can see the hump. Okay, that's the decay curve. Whoop. Okay. Now that's over damped, right? It's squashed everything down. But look when I hit critical damping for the coil. It's just running a double D thing, so it's a bit of a yucky transmit sort of coil. I mean, it's okay. It's got hanger on it. It's it's got parasites. The receive coil's a parasite to it. So, but have a look at this. Okay. Okay. You see how that hump is right up? That is critically damped. So, and when it's critically damped, one thing I've noticed, they're less susceptible, hang on, dry lips, susceptible to hot rocks. Would you believe that? Kalgoorlie hot rock on the coil. And the remains of a mango milkshake, but hot rock, less responsive. So anyway, don't want to worry about the hot rock too much. You can stay there. But see how it changes the decay curve anyway. Hot rock. So we get our little target, 0.05. I don't even know what I've got this on. What's it on? It's on cancel. It's on special fine, which and I'll get rid of some of this paraphernalia off the coil. And that's why I don't wear rings normally, but it was put in front of my face, so I had to wear it. Now, I haven't got this on anywhere near full gain, but we can turn the gain up. I'll just give you an idea. Oh, bloody oscilloscopes. I'd rather keep the picture there than have it crank right up, but I mean, that's getting about double the distance one of these standard would do on that little 0.05. It is a 0. I was making sure it wasn't the 0.1 because it's on that end. But yeah, critically damped. Now, the other thing you can do too is you can, I'll take this off, don't need it no more. The other thing you can do too on this is you can actually overdamp your coils, right? And what that does, it makes them less susceptible to very close ground, okay? Quietens it down. It may knock off a little bit of sensitivity on tiny targets when you do that, because what you're doing is when you critically damp your coil, you're making it as sensitive as hell. And for the electronics to pick up every little tiny speck, it's not getting covered up with oscillations, or you're squashing the decay curve down into the ground. So you can see it actually, the decay curve moving, the leading edge, it's coming in and out. So it is basically selectively moving, so you can let more signal in, or less signal in, and basically capturing more signal on the downward slope of the leading edge. So it's really hard to do it here. I'd rather do it out in the field, but then I can't take the test equipment. So anyway, the 0.05, even it's on lower gain, completely overloads. I'll just turn it up so you can hear it. I mean, and this is on fine gold, but I'll show you what it does on normal too. It's really good for normal. So, and also, I don't know why this is, but sometimes with very tiny targets, now get on the coil. It's to do with the coil, so I was going to loosen that off and explain it. On the coil, on fine gold, very tiny targets happen to be really sensitive around this area here, near that where it says GP, and less sensitive over the rest of the coil. Now, when I critically damp the coil, right? So anyway, when I've got it critically damped as best I can do it, how I'm doing it here. And I wish I had a mono on there, it works better. But the thing is that the detector is, the coil is now as sensitive as hell over the rest of the coil. I don't mean on the transmit side. There goes that ring again. That's why we take these off and put it up there. So yeah, over on the transmit side, because it's a double D, you know, there's not much there. But then we go over this side and we go in the middle of the coil. It's the same all over it on this side. Hope you can hear that. I'll give the audio out full bore. Now it tends to be more sensitive to where you'd think it would be, and that happens to be on that red sticker, because on all other modes it's really sensitive. So I would say that they're possibly, I'm not saying that 100%, but in my opinion, there is some funny business going on with the older double Ds running on fine gold on these detectors with the fixed damping resistor. It's always been that way. So as you can see, I'm right over the red spot of Jupiter. If I didn't have all the background interference, we're getting up here somewhere. It's damn high. The camera's looking down, so it's not giving the proper perspective. But yeah, I had that measuring thing, and David grabbed it. So I've got something. I'm building something else too for doing coils, something for testing coils. Hopefully, I was expecting it to be dropped off today, but it'll be dropped off tomorrow. Now, if I get on here and we'll stick it in normal mode. And that's just gone to a complete mess on the oscilloscope because all the time locking windows are gone out. So, okay. Look at that curve there, right? Now, did you notice that on fine gold, the curve was up? Now it's dipping down. Now, all I've done is change modes. What does it prove? It proves that timing, the way it's set there, is not optimized for that coil. It's not. So let's see if we can whip it into shape. It's massively overdamped. Believe it or not, it's peaked there. I need more gain because there we go. It'll get a bit ropey, but I'll just peak it, see? Yeah, it crashes. What you want to do, you want to peak that hump. I mean, I'm on 100 millivolts per division. You want to look a lot less down than that, but all the time, when everything will go out and I'll have to readjust it all. Okay. Yeah, I'll do it that way. There you go. Look at all the noise it's picking up. Can you see how much it's wobbling around? That's all the interference that's being picked up. And that's where your signals get picked up. They're all sampled off this. In a digital detector with ADC on it, it'll be taking time samples along this curve and all the curves that are in the timing window. And then you just manipulate them and you'll know what's what. Anyway, I won't get into doing that. We'll just continue on. So, okay. See, I'm dropping the height down and it's going back a little bit. And then it didn't go back that much. It's a timing glitch on the oscilloscope. But basically, I'll just turn it up a bit, that wrong way. There we go. So I'll drop that curve down. That will help. You know, normal mode hardly gets rid of hot rocks. So we've got one here, nasty one. Let's just go. You know, I smacked it down hard on the coil, but basically we've just over dampened the coil a little bit, and straight off, having a hot rock on fine gold and then just jumping it straight to normal, normally the detector will scream its head off, but because I've just done the damping, it's fixed it. So, you know, in a later detector design, you could get, I was going to turn the audio down, it's driving me nuts. On a later detector design, you could actually have this variable damping done in the digital domain, and you could also have a automatic scan and for either, you know, critical damped, under or over, and you could do it by a percentage either way, and it would make your detecting a lot better. Also, as soon as you change coils, I want to optimize the damping for that coil, bang, it'll do it. But at the moment, you know, it's all done analog with a knob. And that's a beautiful signal for one of these detectors in normal mode. I've shown you before, standard 5000s, you have to rub that on the coil and it may give a response in normal, but we're in normal fully overload it on the coil. It's not a problem. And that's a 0.05. So let's critically damp it then. Long way. About there. There we go. That's critical damping right there. The power of the coil, power of everything comes right up in there. It makes a huge difference. Normal mode 0.05. I haven't put the gain up or anything. Okay. That far on that in normal mode. Okay. So there's a lot of things you can do with these detectors, these older ones, and get so much grunt out of them. Yeah, and like I say, there's your gain here. I've only got it. I don't know, maybe half. I'll turn it off because it's making a damn racket. Okay. It was. I better tell you, it was closer to 3/4 turned up. So that's screaming, but it has a way it knocks out hot rocks. It's just unbelievable. It really is. But yeah, we better let the glue or the glue stuff dry. So there's our little depth and phase changer circuit. So we can put these in people's detectors, but what we're going to do is that anybody who wants one, we're going to build them up and send them out with instructions, so you can put it in your own detectors. This will go in. I've got to get it right because you need switch damping. It will go in GP Extreme, GP 3000, GP 3500, GPX 4000, GPX 4800, GPX 4500, and GPX 5000. It'll go in all those detectors. And that is just an absolute super boost in performance just by tuning the coil to the detector. And like I'm saying, these double Ds in the receive end have a fixed resistor. So on a mono, this is better again because we can adjust. We don't have a receive coil sitting in there that we can't do anything with, and it's like I call it. It's just a parasite on the transmit coil, trying to get that right. And I'm amazed it actually does it, but it does it. And I think I did use a very early version of this out in the bush with a video I did with Eugene and I think who was it? I can't remember. It was Eugene and was it John? I don't know. I've been at the bush a few times with too many people, but yeah, that's the first one I did. So I'm not going to show anybody what it is. But yeah, that's the one when I built it, I rushed it and I got it some part of it ran the wrong way and it worked in opposite, which wasn't really good. So I redesigned it and I actually used better parts and yeah, it's really stable. Like everything's bypassed properly. I can put my hands all over these, the pot wires here, which is floating in the air. It doesn't do anything. Normally, you hook stuff up to these detectors, and it just wants to pump interference and noise, even transmit pulse and power supply into every wire like a pickup. So you see on this here, I've just got it sitting there wide up as so, and yeah, I'm really happy with that. So that's a really good mod to do to the detectors to apply critical damping. There's another way you can do it, but it's really, have you see how critical I have to move things, right? It's critical. I can expand the range to make it less critical, but I want to cover everything. You throw anything at this, it'll be able to say, oh yeah, I can handle that, and I'll fix it up, and it's going to be beautiful. So there is an issue with changing modes and using fixed damping. It's not ideal. Okay, it's not ideal. I'll leave it at that. So yeah, well, you've seen it. So the only thing is, I have done a field test. I did it when I jerry rigged the other board and went out with Eugene, and we tested it. Ran beautifully, perfect. So sensitive, and you've probably all seen it. And someone's trying to ring me up. It's Jason. Jason is trying to ring me up. But yeah, I'll cut this short, and well, cut it short. It's already gone for over an hour, so it's not really cutting it short. But yeah, I'm trying to get this stuff done. So yeah, I've basically proven the module technique of doing this. So guys, you know, there's a ton of guys over in Africa who'd massively benefit from this on their GPXs. So if someone wants to set up over in Africa doing this, you know, go for it. You know, you probably set up anywhere. You know, even okay, just said I missed a call. Thought it was other messages. Yeah, basically, you know, a lot of people won't be able to do this themselves. You know, they will get out the 80-watt Burco and burn holes through the board. I know that. So if that sort of person, do not do it. We'll see if we can get some people to act as installers, and we could send this module to you or the installers or whatever, and get that done. But I'm also modularizing the, is it a word, modularizing? Modularizing, I don't know. Something I made up. There you go. Making modules up for the receive as well on variable frequency. We can also make modules up for the variable frequency in all the GPs, SDs. We can put variable gain in SDs, and basically all of them all up to the 5,000. You know, when they start using black modules in detectors that people can't tend to get into the resin, it is a problem. But we're applying the same principle here on these. We don't want people getting in there. They'll probably do damage to their own detector. So we're going to seal it all up, and it's potted. And the actual, I've used some potting mix we actually use for fixing metal, right? But it's not conductive. It's got carbide in it, right? So you try and cut it open, it's going to blunten your tools. So yeah, and epoxies are basically more or less this stuff here is chemically inert to everything I've tried to do it. But I'm going to get some stuff. I'm not going to say the name of the company because people will chase it trying to get the antidote and try and fix it. But I don't know if you can. There's a couple of companies out there who make resins that are basically, you're not going to get through it. You're not going to be able to drill it or anything. And this is in particular for, you know, the monkey see, monkey do, monkey copy. They are out there, and I've had it before. I come up and do things, the next minute they're telling me I knocked it off from them. So the thing is, if they can't see what I do, they can't say I knocked it off from them because they've got no idea what I did in the first place because they didn't do it. I did it, right? So, yeah, this game's full of nutters. Some are nutters, And yeah, we've been informed of more nutterish silliness that's been going around too lately. This is getting better and better. Yeah. So anyway, into the files it goes. Anyway, I hope that has excited everybody who has older detectors. Keeping up with the newer detectors. It wouldn't surprise me if that's possibly what's going on with the new detectors anyway, because it absolutely powers on small gold. My God. As soon as you critically damp that coil, bang, up she goes. It's picking up like twice as far as what I've ever done before. And hot rock goes, not there. It's not there. And that's one of the Kalgoorlie monsters. It's just about impossible to get rid of. 3/4 gain in normal mode. Dump it on there. He says, oh yeah, I'll eat that for breakfast. Awesome. I'm impressed with myself. What do they say when you don't? I've outdone myself or something. But anyway, yeah, leave messages in the comments what you think of that. So I might actually get this up and going, and I'll see if I can dig up. Eugene can run around, give it a test for me. He's been detecting for many years. He knows what he's on about, so he can do an independent test of it. So hopefully overnight that glue or that resin completely hardens and we're in business. But yeah, it's very good. And the other MOSFETs, I better tell you a story about the other MOSFET that's in there. It has to be a particular type, and it's now obsolete. But I have about 2,500 of them, so that's going to come in handy. It won't work with any other MOSFET except for one, and it's in there. So I've tried lots, and just yeah, there's criteria it has to meet to make it work. So it works. Anyway, it's 8:15 and I better go and have my dinner or else it's going to be dried out like an old prune in the sun. And yeah, been talking too much. When you talk a lot, you get dry throat, really. So that's some technological marvel for you to look at. We can do this too. I can digitize it and make it automatic. So you just basically put your coil on, hit a, you don't even know if you need to hit a button. Yeah, probably would. I suppose you could actually, if you make it automatic, you can actually turn the tune button into a examination scan button, and you could have part of the circuit look at the noise spectrum with the coil in the air and scan it that way. But you've also triggered scan the coil and let's find out where the critical damping point is. And then away you go. So you could do that. And we could also probably do as well that if you want to be really pedantic and look at the critical damping on the ground you're on, you could probably put the coil on the ground and it would also take into account the mineralization in the ground and critically damp your coil with all that ground reactance. So I've probably given the commercial guys a whole heap of stuff to think about, but yeah, they're not going to go and make this stuff for older detectors. So they can make new detectors that cost many thousands of dollars, and we'll keep upgrading the old ones. So that's what I always say to you guys: don't get rid of your old detectors. I have seen some dealers saying, trade-ins on your old detector. That's just to get them out of the goldfields, I think, because if I was a manufacturer, right, and someone got some old detector and said, well, I'm going to do this and that to it, and it thrashed all the new stuff you're putting out, they wouldn't like it. I would be enemy number one for doing that, because it just doesn't look that good, does it? But yeah, I do like all the new detectors. I still think they're all right, even though I've got two of them and I don't use them. I use my old ones. That's saying something, isn't it? Or should I shut up about that? Yeah, so yeah, I mean, this detector here, this one, is the most versatile detector. It does everything. It's real now. It does everything. It did most of the stuff before. Now it does everything. It is so damn sensitive. Even with an old clunker GP series, 11-inch double D on it. Yeah, it eats it for breakfast. And when I put the Tech coil on it, oh my god, it's so sensitive. It's like a super powerful VLF detector with that sort of sensitivity. It really just smashes it. So yeah, I shouldn't have said all that, should I? I'll probably get inundated. And like I say, I get snowed under with work anyway because it's massive workload doing all these detectors. It's yeah, it is too much. So that's why I want to start doing modules for people and yeah, set it up overseas. If you're in Indonesia, you want to do it, hey, wave your hand. You're over in Sudan or Angola or anywhere over there, wave your hand. If you're in Iran, keep it quiet. You wave your hand in a low profile. Russia. Oh, sorry. I think Belarus, is it? We don't deal with Russia, do we? Oh no. Yeah, Ukraine. Yeah, you want to do it over there? Good. We can supply you modules, and if you have a little workshop and a setup, something like this, well then, you know, you can do it and do up people's detectors for them. You can probably modularize everything and make it really easy. You know what to remove, what to change. Yeah, the whole lot. It should be pretty foolproof. And then I said that it won't be. We'll see how we go anyway. You really have to be technically competent to do this. You can't do it like, if you're a, I don't know, I don't know. I was going to say some stuff, but I just I thought I'd shut my mouth on it. I was going to mention some occupations, but I suppose if you're a funeral director or something, you don't want to do this. Maybe you can use a soldering iron. I don't know. I'm just being crazy now, but no, I'm just happy because this works so good, and yeah, you'll seen it in operation. So rather than going for more than 1 hour and 13 minutes, I'll cut it off. Catches.